So, Assalamu alaikum warahmatullahi wabarakatuh. So, I'm just recording this video because we have already missed two sessions, and I just wanted to discuss at least three papers before your examination commences. I think since your examination has been scheduled in the first week of December, we will meet three times before your examination, right? So I think we have already initiated the discussion of 2023 HSC exam past paper, and I have annotated on this page, and I hope we have discussed this question. Yeah. So let me continue the discussion of the remaining questions of this paper, right? So what I recommend you is just watch this video till the end, even though if you have tried the question. Yeah. Now what you can do is you cannot ask any questions directly, as I am just recording it, right? So you can watch the video. Before that, you have to attempt all the remaining questions, and if you have any issues or doubts, you can just send me a WhatsApp message mentioning the timeline or the screenshot of this video. Then I can explain via a voice note, or at least in the next session I will try to explain. Okay, right. So now in the last class we discussed the question 25, and it has A part and B part. Yeah. So we have completed the A part, and now we will come to the B part. Okay. So now they are asking, explain one advantage of using biofuels compared to fossil fuels. Okay. So now this is the continuity of the 25th question. Now here we have used burner containing octanol, right? So now octanol is a member of alcohol family, right? So alcohol is a biofuel. Okay, right. For example, we can classify the fuels into what do you call? We will study this actually in the module 7. Yeah. So in module 7, organic chemistry. Okay, sorry for that, because I just renamed this OneNote page, and I just had some technical issues. Let me go to the paper discussion. Where are the annotations? Okay, so what I was telling is we will study the advantages and disadvantages of biofuels and fossil fuels in our next module. I mean, in module 7. Yeah. So under module 7 organic chemistry, we will study about this fossil fuel and biofuels in detail. Anyhow, you might have already studied in your previous classes also. Using that knowledge, we can just go to the answer, right? Okay, so now we will just compare and contrast biofuels and fossil fuel. Okay, so let me write over here. Okay, so now they are asking the advantage of using biofuels, right? So now before finding out the advantage of using biofuel, we have to know what biofuel and fossil fuels are, right? Okay, now fossil fuels are made using the anaerobic decomposition of dead organisms, right? So here we can write first we will study fossil fuel. fossil fuel and biofuel. Okay, now here fossil fuels are made using the anaerobic decomposition of dead organisms. Okay, so this is a process taking millions of years, right? So here the main disadvantage is here biofuels are non-renewable, right? So non-renewable because the consumption of biofuels are much greater than the formation. Yeah. Okay, so the non-renewable, right? Because nowadays the current world depends on the renewable energy sources, not on non-renewable energy sources. Okay, right. But on the other hand, biofuels are the alternative to fossil fuel made from biomass, right? So here made from biomass. What are biomass? Biomass are materials produced from living organisms like plants and animals. Okay, right. One of the example is ethanol, right? So ethanol is also the member of alcohol family, and here we have taken octanol, that is also a alcohol. Okay, right. Now we can produce this alcohol in different ways, right? One of the way is, you might have studied about fermentation, where we make alcohol from glucose using yeast, right? So that is a different case, and the equation, reaction, everything we will study under module 7. Now the advantage of biofuel is, now if you want to discuss the advantage of biofuel, we have to consider the disadvantages of fossil fuel, right? So here the fossil fuel have a lot of environmental and health issues. Yeah, health issues, because it can, right? So fossil fuel can produce a lot of carbon dioxide, right? So carbon dioxide will lead to global warming, but here this biomass is called carbon neutral energy source, because the produced carbon dioxide is again consumed by the plants for photosynthesis. So here this is a carbon neutral energy source. Okay, so now the disadvantage, so the advantage is less, right? So this is what you are supposed to write as the answer for this question. Here this is less environmental compared to fossil fuels. Here this biomass has less environmental and health implications. And the other advantage is this is a renewable energy source. Okay, so they have asked to explain one advantage, right? So you can just give this environmental implication, and you can argue that fossil fuels produce carbon dioxide, more amount of carbon dioxide, which will lead to global warming. And sometimes if carbon dioxide dissolve in water bodies, it will produce H2CO3. This is carbonic acid. What will happen to the acidity of oceans and water bodies? The acidity of the water bodies will increase, right? So you can just write these things for the answer of the B part of question 25. Now moving to the 26th question. So here, if you look at the 26th question, this is related to the Oswald method production of nitric acid production. Yeah, so here you can see nitric acid can be produced industrially using the process shown, right? So the method that we use to produce nitric acid is called Ostwald method. Okay, right. So we will just see what this method is, right? So now you can see here production of nitric acid using Oswald methods. So here for this ammonia gas NH3, atmospheric air and water, right? So in atmospheric air we mainly focus on oxygen, yeah? Because 78% of atmospheric air contains oxygen, but we will use oxygen as raw material, okay, right? So now the raw materials are water, atmospheric air, right? So basically oxygen gas and ammonia gas. Now you can see nitrogen dioxide gas obtained by the reaction between ammonia and oxygen gas is reacted with water to produce nitric acid. So first we react ammonia gas and oxygen gas, and we use like around 750 to 900 degrees Celsius, right? And we have to use a catalyst, platinum or rhodium. Now what will happen is NO gas will produce with a water liquid, right? So if you look at this diagram, this flow chart here, now you can see oxygen and ammonia are used as raw material, right? So in the reactor 1, what we insert is, we insert oxygen and ammonia, right? So the reaction happening between oxygen and ammonia is this. You can see here, oxygen, ammonia produce for NO gas and H2O gas, H2O liquid, right? Okay, now what we have to do is we have to use around this temperature, right? Okay, so if you remember this temperature, you might approach the kind of, but anyhow we will study these things in module 8, but you can just understand what's happening behind this industrial process. Okay, so we insert heat also, right? So you can observe the head of the arrow mark. Into the chamber we are giving heat, right? So we provide energy to the reactor 1, and this reaction happens. Now in separator 1, what we do is we just remove the water produced in this reaction. Okay, so here disposal of water happens. After that, now in the chamber, now you can see this is a complete reaction. What will happen? All the reactants will be converted to products. So here we will have only NO gas after we remove all the water. Now what we have to do is, in this mixture we have nitric oxide only, okay, nitric oxide only. Now if the temperature is extremely high, so we have to cool down, right? So now we have to take the heat out by cooling it down. Now in reactor 2, what we have is NO gas is already there, right? So NO gas has already been produced from this reaction. Now we have to insert oxygen to the reactor 2, but now you can see here that we have reduced the temperature to 38 degrees Celsius. Okay. Right. So what we have done is we have reduced the temperature to 38 degrees Celsius, and the pressure that we use in reactor 2 is 8 atm. Okay, atmospheric pressure, 8 atmospheric pressure. Now we have NO gas and we have inserted oxygen gas. So what will happen is we will produce NO2 gas. Now the produced NO2 gas will react with itself and form N2O4, right? So here this is the equilibrium reaction that happens into the reactor 2, right? So now we insert oxygen gas, already we have NO gas, so this reaction will produce NO gas. 2 NO gas are being produced. So the produced NO gas will react with itself and produce this N2O4 gas. Okay, now in the mixture, in the chamber, what we have is we have both NO2 and N2O4, since this is an equilibrium reaction. So now you can see further. Now here we have NO2 and N2O4 mixture. Again what we will do is, into this mixture we will insert water, right? So if you insert water to this mixture, what will happen is NO2 gas will react with water to produce HNO3 gas and NO gas. So in the chamber we have NO gas and H2 HNO3, right? So now HNO3 is aqueous, so it will be like this, right? So in the chamber we will have liquid HNO3, and here we have oxygen gas also, because you can see this is a complete reaction, right? So all the NO2 gas in the mixture will react with this one, right? Okay, now here in the separator 2 we will separate this NO gas, and this HNO3 nitric acid can be transported to the market. So this is the procedure where by which we produce this ammonia gas. Okay, so after understanding this flow chart we will move to the question, right? So now you can again see here emission control. Now NO gas should be reduced to N2 gas and O2 gas using catalytic reduction method, right? So we will study what how this works in module 8. Okay, so module 8 we will discuss about it, but now we will focus on the questions. Okay, right, now they are asking a mixture of NO2 and N2O4 enters reactor 3 where only NO2 is consumed by the reaction with water. Explain with respect to Le Chatelier's principle what happens to N2O4. Now they are talking about this reactor 3, right? So in reactor, a mixture of NO2 gas and N2O4 gas enters reactor 3 where only NO2 is consumed by the reaction with water. Explain with respect to Le Chatelier's principle what happens to the N2O4. Now if you want to apply LCP, we should focus on an equilibrium reaction. Okay, so in so between NO2 and N2O4, this is the equilibrium reaction, right? So let me write down here NO2 gas to NO2 gas becomes N2O4 gas. So what they are telling is a mixture of NO2 and N2O4 enters reactor 3 where only NO2 is consumed. So if NO2 is consumed, what will happen? The concentration of NO2 will reduce. So what will happen? What will happen? So if the concentration of NO2 reduces, the equilibrium will shift to the left side, right? So N2O4 will decompose to form NO2 gas in order to maintain the equilibrium. Yeah, so they are asking, explain with respect to Le Chatelier's principle what happens to N2O4, right? So this is what you are supposed to write. Since here in this one we should okay, now you see here in this chamber we have NO2 and N2O4. Since NO2 gas is reacting with H2O4, what will happen to the concentration of NO2 gas? It will reduce. Yeah, so when this reduces, all N2O4 will tend to form NO2 gas. So you can write here, this is how you have to write, right? So since NO2 gas reacts with H2O to form HNO3, the concentration of NO2 will reduce. So according to LCP, in order to maintain the equilibrium, N2O4 will decompose to form NO2 gas. So now all N2O4 will become NO2 gas, and the formed NO2 gas will again react with H2O to produce more nitric acid, right? So this is what happens, right? So you can see how useful this Le-Chatelier principle in order to predict the scenarios happening in the industrial processes. Yeah. Okay. Now they are asking in B part, explain two improvements that can be made to the design of the process shown. Okay, so here in this industrial process, what are the improvements that we can make? That's what they are asking. Okay, right. Now you see here in an industrial process, we should invest less and we have to get revenue much. Okay, that is the main goal of industrial processes, and we should not waste anything, right? Okay, now here you can see, here now we dispose water from the separator 1, and here in the reactor 3 we add water, right? So now here during the reaction this water is produced, right? So we don't want to actually waste water. This water can be utilized for the addition of this reactant 3, right? So this water can be used to react with NO2 gas in the reactor 3, right? So first method is you can write, okay, for this question, right? So for the B part, the first method is water removed from reactor 1 can be utilized in reactor 3. Yeah, reactor 3. And you can see, right? So in the initial step we provide heat, but now here what will happen, we have to cool down. So when we cool down, we take the heat out, right? And you can see that in the emission control step, again we have to provide heat, right? So now the taken heat or the released heat can be utilized here, right? So the released heat from cooler can be utilized in the emission control step, using proper mechanism. Okay, so this is how you have to write down. Okay, so anyhow, that just you want to know the Le-Chatelier principle in order to answer this question, but we have studied some more things also, right? So how industrial processes work, and we will now you can get an idea of how our module 8 will be. Okay, right. So now moving to the next question, that is 27. A student has been asked to produce 185 milliliter of ethanol, and the molar mass of ethanol is also given by fermenting glucose using yeast, right? So I already told you, right? So in order to prepare bioethanol, we can use fermentation, right? So where we make glucose become ethanol under the presence of yeast. Okay, right? So yeast is a catalyst here. Now, okay, so this is actually this is ethanol, and here I'm sorry, this is glucose, and we produce ethanol, right? Okay, so here this is glucose and this is ethanol, and you can see carbon dioxide is a byproduct. Anyhow, the byproduct can be again used by the plants to for photosynthesis, right? So now this is a carbon neutral method, or carbon neutral biofuel. Okay, right. Now given that the density of the ethanol is 0.789 gram milliliter minus 1, calculate the volume of carbon dioxide gas produced at 310 Kelvin and 100 kilopascal. Okay, so now assuming that this reaction is happening in a closed vessel, now we just put glucose solution and we put yeast also, right? So what will happen is at the end of the reaction we will have ethanol and CO2 gas. Now they have given that the volume of this one and the molar mass of this one also. Okay, and if you have a brainstorm in the exam, what you have to do is you have to write down all the things and you have to try to make relationship between the given hints. Okay, right. So now we have been given that, right, so you can see for ethanol, right, so for ethanol they have given volume is equal to 185 milliliter, molar mass is equal to 46.6068 gram mole minus 1, and they have given the density of this ethanol, right? So the density is equal to 0.789 I'm sorry 9 gram milliliter minus 1. So now if I know density, I know the equation density is equal to mass over volume, right? So that now I can find out the mass of ethanol, right? So this is mass of ethanol, so that will be equal to D into V, so 0.789 into 185, it will be in gram, right? So here where's my calculator? Okay, so this is equal to 146 gram, right? So 146 gram. Okay, now if I know the mass of ethanol, we have been given the molar mass, so I can find mole of ethanol. Mole of ethanol is equal to 146 gram divided by the molar mass is 46.068 gram mole minus 1. So this will be equal to so here so I get 3.17 mole, right? Okay, now here this is a complete reaction, so I can use this stoichiometric ratio in order to build relationship. Yeah, so now if okay, right, so now you can see here if this reaction happens, we produce 3.17 mole of this ethanol. Yeah, okay, now if we produce this amount of 3.17 mole of ethanol, we will produce the same amount of carbon dioxide, right? So now considering this carbon dioxide as an ideal gas, I can use this ideal gas equation. PV is equal to nRT, as I have been asked to find out the volume of carbon dioxide, right? So I have no other idea. So here this is known, the temperature is also given, the volume, yeah, the volume is also given. Yeah, no, we have to find this volume, right? But we have been already given the volume of this ethanol. We cannot use it, right? Okay, so now the pressure is also given as 100 kilopascal. So V is equal to nRT divided by P, right? 3.17 into R is equal to 8.314 into this T is temperature is given in Kelvin, 310 divided by our P is 100 kilopascal, right? So we are supposed to put it in 10 power 3. So if you feed the values in the calculator, you will obtain I think 80. Let me do it again. 3.17 into 8.314 into 310 divided by 10. I'm sorry, 10 power 4. Oh, I made a mistake here. Okay, right, so this is supposed to be 100. Okay, so 10 power 5. Okay, so you will obtain the answer as 0.0817 meter cube, right? So anyhow, we better mention the volume of this in liter, so it will be equal to 0. I'm sorry, 81.7 decimeter cube, or 81.7 liter. Okay, because yeah. Okay, now now we assume that this is a closed vessel anyhow, but this cannot be a rigid one, right? Because it has to confine this gas also. So this is just I took, right? So don't worry about that. Now moving to the 28th one. This one we will study this in the, okay, so here we will study this in module 8, right? So I don't want to explain this. If you look at the past paper, most of the questions are asked from the module 6 and 5. You can feel that if you have experience in this kind of things. Okay, right. So what about 29th one? Yeah, 29th one also we haven't studied. This will be in module 8, okay? Because we have to study organic chemistry and then module 8, yeah. Okay. Question 30. Now, question 30 you might have already studied it, right? Because this is inorganic chemistry. A water sample contains at least one of the following anions at concentration of 1 mole liter minus 1. So here we have a solution. It has Br minus and carbonate ions, okay, CO3 2 minus. Outline a sequence of tests that could be performed in a school laboratory to confirm the identity of the anions present, right? So include the expected observations and 2 balanced chemical equations in your answer. So now in order to identify Br minus, we can simply use this silver nitrate, okay, right? So if you use silver nitrate, so what will happen, Ag, now the test, right? So we'll begin with now this is how you can write down the answer. Test silver nitrate observation. What will happen, we will observe creamy precipitate, okay, creamy precipitate of AgBr. So they have mentioned to include a chemical equation also. So Ag plus aqueous plus Br minus aqueous will give you AgBr, okay. So this is what you are supposed to write, and don't forget to mention the physical states. So because this is an insoluble salt, you have to put a solid state, okay, right? For CO3 2 minus, the simple test is you can just put an acidic medium. So if you just put some drop of acidic solution, what will happen, the test is for example, you can add any acid, right? For example, let's say test add nitric acid. So if you add nitric acid, you can observe bubbles, yeah, because carbon dioxide will be formed, right? So the observation is you can observe bubbles. Okay, so the chemical reaction happening here is CO3 2 minus plus, you can just mention H plus equals, yeah, because if you specify this nitric acid, you can put HNO3, or otherwise you can just put H plus. It will give you what do you call, CO2 gas plus H2O gas or liquid, because yeah, so if you just put CO3 2 minus in acidic medium, it will produce H2O gas, I'm sorry, H2O liquid and CO2 gas. So due to this CO2 gas, you can observe bubble in the sample. Okay, right. Moving to the next one here, 31. Copper 2 ions, copper 2 plus forms complex with lactic acid. Okay, so since we have concentration, initial concentration, absorbance. Okay, let's try to give it a try. Okay, so copper 2 ions form a complex with lactic acid as shown in the equation, right? So here we have copper 2 plus, and this is lactic acid, and this is a complex, and you can see that this is an equilibrium reaction. Okay, so this is what we can know from the sentence we have about this chemical equation. This complex can be detected by measuring its absorbance at 730 nanometer. A series of solutions containing a known concentration of this was prepared and their absorbance measured. Okay, right. Yeah, they have asked to sketch a graph also. So when we are asked to sketch a graph, first we have to identify what we are going to mention in x-axis and what we are going to mention in y-axis, right? So now what we are changing is, you can see a series of solution containing a known concentration of this, right? So what we know or what we change can be mentioned in x-axis, right? So in x-axis we are going to put the concentration of this one, okay, this complex ion, and the absorbance is what we measure, right? So what we measure can be put in the y-axis, right? So here absorbance, right? So now we have identified the axis of this graph. Now two solutions containing copper 2 plus and this were mixed. The initial concentration of each in the resulting solutions given in the table. Okay, so if you know the initial concentration, and if we have what do you call, equilibrium reaction, what we can do is we can set up the ice table. Yeah, so let's try to construct this ice table. Okay, so after identifying the axis, we will just try to construct the ice table. So in the ice table, the equation that we are going to include is Cu2 plus aqueous plus lactic acid 2C3H6O3 aqueous gives this complex, okay, and the coefficient is 1, right? Okay, so if I construct this ice table, initially we have 0.056, and this should be in concentration, right? So I already told you in ice table we better always put the concentration. Even if you have been given mole, if you have the volume, then you have to find the concentration and substitute in the ice table there, so that you can easily achieve the answer. Again we have lactic acid 0.111. So now if you read the question carefully, you can understand that this complex can be detected by measuring its absorbance at, okay, now we have to detect this complex at this 730 nanometer. Okay, right, that is not actually needed here. When the solution reach equilibrium, its absorbance at 730 nanometer was 0.66. Okay, so now we have been given this graph. What we can simply do is, you can just try to plot this graph. Okay, right, so here we will mention that the concentration of the complex, and here we will mention the absorbance. So here we have been given this data. This is like in your previous grades in mathematics, you will be given x and y. So here we will be given x like -1, 0, 1, 2, like that, and here we will be given and like some values, missing values will be there, and they will give some equations also, like 2x minus 3, and you are supposed to find y, right? So likewise we have been given a table. So concentration starting from 0 and the interval is 0.01, 02, 05, right? So now I can just take each box, like this box, right? So if this is 0 and this is 0.01, 0.02, 0.03, 0.04, 0.05, and again in absorbance we have 0 to 0.72. So I will just take this as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Yeah, right, because the maximum value is 0.2, right? So here we will just try to plot this graph. Here 0.0, right? So the coordinates are 0, 0, and then 0 point, the corresponding y value for 0.01 is 0.13, 0.1 is here, 0.11, 0.12, 0.13 here. Okay, right, again we have the corresponding y value for 0.03 is, let me, 0.28. Yeah, 0.28 means kind of here. Oh, here I'm sorry. Zero point 3 will be somewhere here, because you see, each small point will be 0.1 divided by 5 is equal to 0.02, right? So if we want 0.03, it will be something like this. Okay, not here. So we need 0.13, 0.12, and the half of the second small box. Here we have the second point, and then we have 0.28. Yeah, 0.2 is here, and 0.2 is here. 0.48 will be on fourth one here, because 0.20, 0.22, 0.24, 0.26, and 0.28, right? So it will be here. Okay, again we have I think you can understand how to plot this graph. 0.43, yeah, so 0.4 is here, and 0.2 is here, 0.4 is here. In between this we have this. Okay, I don't know if you can see my pen point, but here this is here. Okay, not here. Corresponding value for 0.03. Again 0.0457, 0.57, 0.5 is here. Okay, let me use my mouse. So 0.57, the corresponding y value for 0.04, 0.5 here, 0.52, 5 5 2 5 4 5 6 5 7 means somewhere here. Right. 0.57 here. Okay, right. Again we have where is this? Yeah, 0.72. Yeah, so 0.72 is somewhere here. Now we will try to draw the best fit for this. I'm just using my ruler. Okay, so if I try to draw this graph, it will be something like this. So I will just try to connect this point and this point. I will just try to connect the first and second point. So this will be similar to like this. Yeah. Okay, so I have just roughly drawn this graph. Okay, fine. So now what we have to find is, they are telling when the solution reached equilibrium, at equilibrium, the absorbance was 0.66. So now we have to find out the corresponding concentration of the complex at 0.66. Yeah. So the 0.6 is somewhere here, and the x value is 0.0 here. Again here also 1 2 3 4 5, right? So 0.01 divided by 5 is equal to 0.002. So here we will get 0.0046, right? Okay, now here this value is 0.046. This value is 0.046. okay, right? So now we have found out the change, yeah, change in our ice table. Okay, so in our ice table what happens is, at equilibrium this amount of change is happening, right? So the change is, right, so the change is 0. What is the value? 46, if I am not wrong. 0.046. Yeah. Yeah. So 0.046. At equilibrium we have this amount of complex, which means we have this change, right? So initially zero, now the concentration is increasing. Now at equilibrium the change is this, okay, the change is this amount. This means minus 0.046. You can understand, I think, right? So at equilibrium Okay, so if you wish, you can understand this way, right? So now if you have the concentration, right? So now the absorbance is due to the concentration of this complex. Now if the complex concentration is 0, there is no absorbance. Now when the concentration increases, the absorbance also increases. At equilibrium we have 0.046, right, which means the change itself is the equilibrium, because initially we didn't have any complex. Now we have 0.046 mole decimeter minus 3 of the complex, which means we have that amount, that concentration is the change, right? So minus, now if this is minus 0.046, that will be equal to minus 0.092, okay, because the according to the stoichiometric ratio, okay, right? So now I plus C is equal to E. Now if you add these two, it will get 0.56, I think 0.01, okay, and here 0.111 minus 0.092 is equal to 0.019. So what they are asking is with the support of a line graph, calculate the equilibrium constant for the reaction, right? So now at equilibrium, right, so this is what I found out. At equilibrium we had this amount of complex, so this should be the change, so from that we have found out the concentration of the reactants and products at equilibrium, and we are supposed to find the equilibrium constant. So equilibrium constant K is equal to concentration of complex, right? So I am not writing that completely, you can write it, and concentration of copper 2 plus and concentration of this lactic acid, okay, I'm just writing lactic square, but you are supposed to write the chemical symbol of these things. So this will be equal to 0.046 divided by here this is 0.01 into 0.019 square. So if you simplify this, here mole decimeter minus, I'm sorry, here I'm writing mole decimeter minus 3, this mole minus decimeter minus 3, so ultimately the answer will be mole minus 1 decimeter, moles minus 2 decimeter 6, okay, right? So if you simplify this, you would obtain 0.04 divided by 0.01 times 0.019 square, 1080. Let me check again. 0.046, yeah, if I made a mistake, yeah. 0.019 square. So this will be equal to 12742.3 moles square decimeter minus 3. So if I write it in scientific notation for two significant figures, right? So this will be equal to, now I can just write 1.3 into 10 power 4 mole square, mole minus 2, okay, so this is just, so this is the accurate answer. You can just give this answer as the answer. Okay, so this can be written as how in the answer script they have given 1.3 into 10 power 3, so you can just write like this. So 1.27 into 10 power 4, 10 power minus 4, I'm sorry. 10 power 4 10 power 4. So this is similarly equal to 1.3 into 10 power 4. So this is the answer they have given in the answer script, but this would be fine. Okay, so moving to the next question. Here yeah, the ammonium ion content of mixtures can be determined by boiling the mixtures with a known excess of sodium hydroxide. This converts the ammonium ion into gaseous ammonia, which is removed from the system. Okay, so they have a mixture, right? So the mixture contains ammonium ion, right? So NH4 plus. So what they do is can be determined by the boiling mixture. Okay, so we just make it react with OH minus, and it produces ammonia gas plus H2O gas. Okay, so now this OH minus is in excess in order to ensure that all the ammonium content is made react. So here NH4 plus excess OH minus, we have ammonia H2O. So they have given the excess sodium hydroxide can then be titrated, right? So now the remaining, right? So now you see here NH4 plus OH minus gives ammonia plus H2O. And here we will have excess OH minus. This OH minus titrated, right? So I think I already explained you the basic concept of titration. Now we just make titration with H plus, it will give you H2O. Okay, so these are the two reactions that we are going to consider here. Now this titration is repeated 4 times. So in each titration we have measured the volume. Now the purpose of repeating this titration multiple times is to get an accurate reading, right? So we will just get the average of the number of titration. Now here the first titration 22.65, then 22.05, 24 to 21.95. So here basically we will ignore the odd values, I mean the outliers. So here you can see that 22.65. Now if you look at the differences between these values, here between 0.05, here also 0.05, but here between the 0. Large value, right? 0.65. I'm sorry, 0.6 mean it is there is a huge difference between the first titration and second titration. So here the titration 1 is an outlier because some error has occurred, right? So we will just ignore that. We will not consider the titration 1. Now in order to find the average HCl volume, average volume of HCl can be calculated by using this formula 22.05 plus 22 plus 21.95 divided by 3. That will be basically 22 milliliter. Okay, right? Because since this is an outlier mean an odd value, right? So that is an alien value, odd value. We will just ignore that, right? So here we will just add these 3 and divide by 3. It will give you 22 milliliter. So here they should have given the concentration in, right. So here they should have given the concentration of this HCl, right? So let me read it quickly. A fertilizer containing ammonium ion was analyzed as follows. A sample of fertilizer was treated with 50 milliliter of sodium hydroxide, right? So the sodium hydroxide is, now we take this concentration and this volume, right? So we have taken for the entire experiment 50 milliliter, right? So the total mole or the total amount of NaOH is equal to 1.124 into 50 into 10 power minus 3, that will be equal to 1.124 into 50 is equal to 56.2. Yeah, 56.2 into 10 power minus 3 mole. Now this now this amount of sodium hydroxide we have taken, and we have to find out the mole of ammonia using this formula, and the excess amount of NaOH will be titrated with H plus, right? Now we have taken, right? So now, okay, so continuously let's read it. After all the ammonia was removed, right? So after the first reaction has completed, the resulting solution was transferred to a 250 milliliter, right? So now we have 250 milliliter solution. Now it contains water and remaining OH minus only, right? So remaining OH minus only. Now we are going to take only, okay, you see here 20 milliliter of aliquots. Aliquots mean a small sample of a large sample. In order to perform chemical experiments, we are taking a small sample. Okay, right. So here this is 20 ml, and with each 20 ml we have performed titration, which means 20 milliliter of HCl reacts with 20 milliliter of OH minus solution. Okay, right. Now this is the concentration of our hydrochloric acid. Now we can find out mole of HCl, right? So that is concentration into volume, right? Concentration is 0.1102 into 22 into 10 power minus 3. This will be equal to, I'm just writing here and there. Anyhow, I hope you can understand the scenario happening behind this experiment. Okay, right. So NHCl, HCl is equal to 0.1102 times 22 is equal to 2.4244. 2.4244 mole. Okay, right. Now you see here we require, right, according to stoichiometric ratio, if you have into 10 power minus 3, if you have 2.4244 10 power minus 3 mole of HCl, only this amount will react with this OH minus. Okay, right. So now this is equation 1, this is equation 2, this is titration reaction. So if you consider this titration reaction according to stoichiometry, what will happen? If you have this amount of HCl, you will require only this amount of NaOH. So the remaining we should have reacted with ammonium ion, right? So the amount of NaOH reacted with NH4 plus is equal to 56.2 minus 2.42 it's a very big value. Oh, I'm sorry. Here you can see here this amount, right? So this amount is in only 20 milliliter, but we have to find out the number of OH minus NaOH in 250 milliliter, because this is the original OH minus that we have, right? So if you have this amount in 20 milliliter in 250 milliliter, how much will be there, right? When the concentration does not change, the amount of the substance will be proportional to the volume, right? So now, okay, I have I'm really sorry, because this is a big value. Yeah? So here, before that, we have to find out, right? So I'm sorry, because I forgot that we have taken only 20 milliliter. So this is in 20 milliliter only, but in 250 milliliter we have, if 20 into if we have this amount, oh, what is the value? Oh, right. So this is in 20 milliliter only, right? So in 20, okay, so you can write in 20 milliliter. So now you can write the amount of NaOH in 250 milliliter. That will be equal to, if we have this amount in 20 milliliter in 250 milliliter. So let me calculate it. So you get 30.35. So 30.305 into 10 power minus 3 mole, right? So now you see here, right, now only this amount is reacting with H plus. Okay, right. So let me explain it again. Now we have taken 250 milliliter of solution after making the ammonium content reacted with OH minus, right? So here what we will have is ammonia gas, and okay, ammonia gas has evaporated. Now we will have only OH minus. Now OH minus, right? So here we have OH minus. Now here we have taken only 20 milliliter for titration, right? So now we take 4 small samples and we titrate it. Right? So these are burates. Okay, right. So now we take the volume of the reading of this burate. First one is 22.65, this is 22.05, this is 22.00, then this is 29.95. Right, now we will just ignore this because that is an odd value. Now considering these three titration, we have found out that the average volume of HCl is this. Okay, right. Now according to stoichiometric of this titration reaction, we know that if we have this amount of HCl, we will require the same amount of NaOH. Okay, right. Now if you have now you see here, what does it mean? If you take 1, right? So if you combine these three and if you write like this, now if you have NaOH and you titrate it with HCl, now here we have 20 milliliter we have taken and we require 22, right? So the amount of NaOH in 20 milliliter is the same amount. So the amount of NaOH in 250 milliliter is, if we have this amount in 20 milliliter in 250 milliliter, how many we have, right? So this is what we have to find out. Okay, right? So we have done. Okay, so with that we will see the amount of NaOH reacted with ammonium NH4 plus ion. So here this will be equal to, now you see here we have partitioned this OH minus to react with acid and this ammonium content, right? So if you, okay, right, so if you have found out the, right, so you see here we have 56.2 into 10 power minus 3 mole of NaOH. This is what we already had, right? Now only 30.305 has been is remaining, right? So only this amount is remaining. The rest should have reacted with ammonium ion. So we can find this one, this will be equal to 56.2 into 10 power minus 3 minus 30.305 into 10 power minus 3. Okay, right. So this will be equal to 56.2 minus 30.305. Okay, so this is equal to 25.895. 29.85895 into 10 power minus 3 mole. Okay, so this amount of NaOH has reacted with NH4 plus. Now we can simply find out this, right? So now we have to just check if the reaction is balanced. Okay. Yeah, this is the equation that they have given, right? So if we have this amount of OH minus, we will require this. Okay, now we should have this the same amount of OH minus, right? So according to the first equation, right? So this is not the first equation. Yeah, so according to the first equation, I can tell like the amount of NH4 plus in the whatever fertilizer or whatever in the mixture is equal to this, the same thing, right? So 29.895 into 10 power minus 3 mole. Yeah, right. So what they have asked calculate the mass of ammonium ion, right? So mass of ammonium ion, mass is equal to mole into molar mass. Is the molar mass given? Simple. If this is not given, let's check. Yeah, if it is not given, you can just use this, right? So M is equal to 29.895 into 10 power minus 3 mole into for nitrogen, that is 14 plus 3. Yeah, so here 14 plus 3 means 17 NH4 plus gram mole minus 1. So this will be equal to 29.895 into 17 is equal to 508. Wait. Oh, I just realized the answer key is finally 0.46. Give me a sec. Oh, 14. Yeah, I'm sorry. NH4 plus, no. So NH4 plus mean here we have 4, right? So 18. 18 means a kind of 29.895 into 18 is equal to 538. 538 means 0.53811 gram. Okay, so this is the mass of the ammonium content in the mixture. Yeah. Okay, so hope you have understood it, right? So I just explained it, right? So you can just rewind and watch the explanation from the beginning so that you can understand. And if you still don't understand, I will explain in the next class, inshallah. Okay, so moving to the next question. So here gases A2 and B2 are placed in a closed container of variable volume as shown, right? Here we have been given these gases, right? So into this kind of container with a movable piston, we have A2 gas and let me write it beautifully. We have A2 gas and B2 gas. Now this is a closed container of variable volume, right? So variable volume means what? The volume can be changed, right? So that's why we have movable piston here. The reaction between these substances is as follows, right? So here we have an exothermic reversible reaction. Now the amount versus time graph is given. Okay, so normally we draw concentration versus time graph, but anyhow amount, yeah, okay, because okay, that's fine. The following graph shows changes in the amount in mole of these three substances over time in this container. So initially, now you see here A2, B2. Now the dotted lines represent the reactants and the solid line represents the products. So here what happens, initially the concentration of the product increase and attains equilibrium at 4 minutes, yeah, 4 minutes, and this decreases. So here after that again another equilibrium is established. Okay. So here what you have to, so this is what we can understand from this. Explain what is happening in the system between 6 minutes and 8 minutes. So 6 minutes and 8 minutes, definitely the equilibrium is at equilibrium, right? So nothing, you have to write, so the equilibrium is attained at 4 minutes, and 6 to 8 again it's at equilibrium. The concentration of the amount of the reactants and the products are constants. Okay, so you can write those things, right? So at equilibrium the concentration are constant and the rates are same, right? So the forward rate and the backward rates are same. This is what you have to write. So whatever you know about this equilibrium you can write in order to obtain marks. Explain two different factors that could result in the disturbance at 8 minutes. Now again you see here at 8 minutes what happens, the equilibrium is disturbed, right? So the reason may be the temperature change, right? So what happens, now you can see that now here nothing happens, right? So for example, if the concentration, or if only if the concentration of all the species increases, then we can say that the pressure has been altered. Or if at least if the concentration or the amount of the reactants or the products, right, of, you have to understand, right? So only the concentration of the reactants or products. So I think we have already done a similar question, right, where we just changed the concentration of only the products, and then the similar graph we discussed, I remember. So here what happens is, here only the temperature change occurs, right? So the temperature. Explain two different factors, right? Okay, now the equilibrium can be affected by many factors like temperature, inserting the reactants or products, and pressure, volume, right? They asked to explain the two different factors. So let's see that what will happen. Now, right, so now we cannot, okay, now you see here we cannot add, now we don't add these reactants or products because the concentration of anything has not changed, right? But now we can add pressure, right? So if you increase the pressure or decrease the pressure, this might change. So how can you increase or decrease the pressure? By altering the volume only, right? So now what we can change is, now we can change the volume in order to change the pressure, right? Okay, so now we will just discuss what will happen if you increase the pressure, right? So now what happens is, here the reactants, right? So the reaction favors the reactants, which means it is shifting to the left hand side. So now we can discuss in the context of temperature and volume, right? So if you right, so since this is an exothermic reaction, so if you increase the temperature only, this will happen, right? So the factors can be increasing the temperature, right? So first one, increase the temperature, right? So I already told you, right? So if it is an exothermic reaction, if you increase the temperature, the reaction will favor to the left, and if it is endothermic, the vice versa will happen. Yeah, right. Now with that idea again, okay, right, so here we have 3 moles and here we have 2 moles, right? So now what, okay, now if you increase the volume, what will happen? The vice versa of pressure will happen, right? So if you increase the pressure, the equilibrium will shift to the direction in which we have less amount of moles, right? So but the vice versa, if you increase the volume, what will happen? The equilibrium will move to the direction in which we have higher amount of moles, right? So here again, if you increase the volume, right? So the 2 factors or the 2 measures that we can do to disturb this reaction according to this graph is increase the temperature and increase the pressure. So you can write, right? So increasing the pressure will favor the reaction to the reactant, since this is an exothermic reaction. And again you can write here, if you increase the volume, what will happen? The reaction will favor to the direction in which we have a higher amount of moles. So this is what you are expected to write for this question. Okay, so moving to the 34th question. Right, so 34th question says, when 125 milliliter of magnesium nitrate solution is mixed with 175 milliliter of 1.5 mole decimeter minus 3 sodium fluoride solution. Okay, so 0.6231 gram of magnesium fluoride, the molar mass of that substance is also given, precipitates the KSP of magnesium fluoride, right? So whatever I know, I have to write. Okay, right, so I know that the KSP of magnesium fluoride, right? So magnesium fluoride is a solid. Now it will dissociate as out. Magnesium 2 plus and 2F minus. So KSP is equal to 5.16 into 10 power minus 11. For this I can write down the expression for KSP. KSP is equal to magnesium 2 plus concentration into F minus concentration power 2 divide, yeah, that's all, yeah, is equal to this 5.1 into 16 into 10 power minus 11. Okay, so when 125 milliliter of magnesium nitrate solution, right? So here we have magnesium nitrate solution, MgNO3 twice, 125 milliliter is mixed with 175 milliliter of 175 milliliter of sodium fluoride, NaF. Right. So now if you look at these 2 substances, they are soluble things, right? So you can write magnesium NO3 the concentration is also given 1.5 m, right? So now we can find mole of MgNO3 twice is equal to 1.5 into 125 into 10 power minus 3, that is equal to okay. So let's read the question again. Okay, right. So what we do is 125 milliliter of magnesium nitrate solution is mixed with here 125 milliliter magnesium nitrate solution is mixed with, yeah, I'm sorry, here the concentration of sodium fluoride is given. Yeah, so here sodium fluoride 175 milliliter and 1.5 mole decimeter minus 3. Okay, so now I can find the mole of NaF, that is equal to 175 into 1.5 into 10, I'm sorry, I can write 1.5 into 175 into 10 power minus 3 mole. So that will be equal to 1.5 into 175 to 262.5. 262.5 into 10 power minus 2. So I can write simply minus 3 now. 0.2625 I can write 0.2625. And also they have given the magnesium nitrate okay, wait, let me read the question again. What happened? I'm sorry. Right, so let me read the question again and extract the information. Right, so what they tell is when 125 milliliter of magnesium nitrate solution is mixed with, now here we have 125 milliliter of magnesium nitrate, okay, is mixed with 175 milliliter of 1.5 mole liter minus 1 sodium fluoride. This is sodium fluoride, a solution, precipitate, right? So now it gives a precipitate of 0.6231 gram and the molar mass is given, right? So I can simply divide it by 62.31, so that is equal to, I think, 0.01, yeah, 0.01 mole is the amount of precipitate, right? So this precipitate is magnesium fluoride, MgF. Now the reaction happening here is magnesium 2 plus plus F minus gives magnesium fluoride solid. Yeah, that's all. Okay, now we have to find out the magnesium 2 plus concentration. Yeah, so before that we can find out the mole of F minus, right? So from this, mole of F minus is equal to, just multiply these two and obtain 1.5 into 175 into 10 power minus 3. Yeah, I'm just writing here 1.5 into 175 into 10 power minus 3 is equal to 0.263, yeah, approximately 0.263 mole. Okay, right. Now you can see that we have to find out the concentration of magnesium using this, right? So we already studied KSP is equal to Mg2 plus into F minus square. Okay, right. Now we have to find out the remaining F minus. Now you see here, if you consider this as a reaction like this, okay, now in order to make this precipitate, how much of this Mg2 plus is required? This is what the question is asking. Okay, right. So now here you can see that 2F minus Mgf2, yeah, I'm sorry for that. Okay, Mg2 plus 2F minus Mgf2, right? So in order to make this precipitate, we have this amount. We have this amount of F minus, but only this amount is being produced as precipitate. So remaining F minus is equal to, we can tell, like already we have this amount, right? So if you have, if this amount 0.01 mole of MgF2 is produced, twofold of this amount will be consumed, yeah. So you can see that 0.213 minus 0.02. Why? Because if 2 moles of F minus is consumed, if 2 moles of F minus are consumed, only 1 mole of MgF2 will come, right? So that's why I just take the twofold of 0.01. So this will be equal to 0.013 mole. Okay. I'm sorry. This is 6. Okay. This is 6 means 0.63. So from this we can use this KSP equation. For that I have to find the concentration of this F minus, right? So after these two solutions are added together, we will have so here you can see 125 125 and 175, right? So now F minus concentration, if you know F minus concentration, I can substitute here and find out the Mg2 plus concentration. So F minus concentration is equal to, we have this amount of remaining oh, again, I'm sorry. Here 0.23 means 0.43, yeah? Right. So here 0.43, I'm sorry. Because we already found that 0.23263 minus 0.02 means this is 0. Why am I making such mistakes? Okay, so that is equal to 0.243 gram. Okay, I'm thinking something else in my mind. Okay, so F minus concentration will be equal to, now this will contribute to the KSP, right? So this F minus will contribute to the KSP. So F minus concentration contributing to the KSP is equal to 0.243 gram divided by, I'm sorry, this is mole, yeah? Why? Mole this is also mole. So 300 means 0.3 decimeter cube, so that is equal to 0.808 mole decimeter minus 3. Okay, right. Now I will plug this value into our KSP value, KSP expression. So I can write 5.16 into 10 power minus 11 divided by this F minus square. 0.808 square is equal to Mg2 plus concentration. So Mg2 plus concentration is equal to 7.9 into 10 power minus 11. 7.9 into 10 power minus 11. So in order to precipitate this amount of magnesium fluoride, we should have this amount, this concentration, this amount of Mg2 plus into the solution, right? So yeah, so what we have done is whatever we know, we have just substituted. Yeah, okay, right. Moving to the 35th question. Right. 0.2 mole decimeter minus 3 solution of dichloroacetic acid has a pH of this. Dichloroacetic acid is monoprotic. Calculate Ka for. Okay, now this is a very simple question, yeah, because if you know the pH, you can find the H plus concentration is equal to 10 power minus pH, that is equal to 10 power minus 1.107, that is equal to 0.0782 mole decimeter minus 3 is minus 3 is the concentration of H plus. Now I can just write down the dissociation equation for this monoprotic acid. So CHCl2COOH becomes CHCl2COO minus plus H plus. So Ka is equal to nothing but this CH2COO minus concentration H plus concentration divided by the acid concentration HCl2COOH, right? Now I have to find this one. So here they tell this is the concentration and the concentration of H plus and OH minus. If this is X, this is also X, yeah. So 0.0782 square divided by 0.02. Wait, because it should have dissociated, because this is the initial one, so I have to construct this ice table. Okay, so let me construct this ice table. I will just shift this. Now we will just construct this ice table. ICE, initially we have 0.2 and 0, 0, and the change is what we have 0. Minus 0.0782, 0.0782 plus plus. So here 0.0782, if you subtract it, 0.2 minus, so it becomes 0.1218. So here in the denominator you are supposed to put this one, 0.1218, yeah? 0.1218, right? So that is equal to 0.0501. Yeah. Now mole decimeter minus 3 is the unit, right? So you are supposed to write along with the unit, right? So even though it is a simple question, don't forget to subtract this change from the initial concentration as I did, right? So we have, I think, two more questions. We will, okay, now we can just discuss this B part, and yeah, this is the 8th unit and 7th unit. Yeah, we will just discuss the remaining questions, and we can just start the discussion of 2014 in the next class. Yeah. Okay. Right, the following data apply to the ionization of acetic acid and trichloroacetic acid. Explain the relative strength of these acid with reference to the data. So pKa value, yeah, okay, I think I didn't teach you about this pKa. Now this is in our 6th unit, right? So we can just focus on our 5th unit alone, I mean module 5, but we will discuss this question later, okay, because I didn't teach you about this pKa and related theories, okay, so we can just skip this question, but this is also very simple. Okay, so I think you have understood all the questions. Now in the next class we can probably start the discussion of 2014 final HSC exam paper. Okay, so I will just send the paper, you can just try, and after completing the 2024 paper we can go to the 2022. Okay, so we have practiced 3 past papers before your exam, so that you can confidently go and write the exam, right? So this is actually the final paper. Now when we are attempting these final papers, you may have a confidence that you can ace this exam, right? So there is nothing. So okay, bye.